Hello students, welcome back. In this video, we're going to put the finishing touches on Nova Strike. These are going to come in the form of visual game polish, systems that we can add to our game that are going to make our game just look better and engage with our user a little bit more. And so this is going to come in the form of three systems that we'll implement in this video. We'll create a particle system so that every time we destroy a ship, it will explode into particles like fireworks on our screen. And that is something that I always love to see. It always makes the gameplay feel alive when we have particles. We'll then add a flash overlay to our screen anytime we create a bomb. So right now when we make our bomb, it's just going to create that bomb radius. But what we'll do is we'll flash the whole screen and then fade it out in time. And then third and finally, anytime we, the player, take damage, we're going to shake our screen. So we'll have a screen shake that takes the whole canvas and moves it randomly left and right, up and down, giving visual feedback that something bad just happened. So let's head to the computer screen and let's work on adding this visual game polish. So I have lesson 8's starter file open here in vscode.dev. I'm going to minimize the browser and open that file directly. So I'll come over here to Nova Strike and I'll open up lesson 8's starter file. All right, so let's see what we got so far. So here we go. Our damage systems are in place. I can damage the player, but no particles yet. I would really love to see those things explode. How about flashing the bombs? No bomb flash and no screen shake when I take damage. So the idea is there. We've got the idea for this visual polish, but we have to implement it. And that's exactly what we're going to do here in our 8th and final lesson of Nova Strike. So we'll come down here to our mission checklist. Mission 1 says we have to set the game polish constants. We're adding new systems to our game. This time they are visual systems, but they're no different. We find those in our student edit zone. This is where we have our knobs, our dials that we can tweak and turn to finally adjust a system to change how it looks, plays, or feels within our game. So we have knobs for our player system, our star system, our bullet systems, our bomb system, our shield system, our ramp system, our enemy system, our damage system, and lastly and finally, our polish systems. So in our polish systems, we have three things. We have particles, we have a bomb flash, and we have a screen shake. And so let's look at each of these systems independently. We'll start with the particle system. Every time we destroy a ship, a bunch of particles are going to be created. How many particles do we want to create each and every time we explode a ship? Right now it's set to 0, which is not fun at all. We want to create lots of particles. Let's be irresponsible. No, I'm just kidding. That would be very irresponsible. You might want to test it, but I'm going to be responsible and set it to 25 particles. I think 25 particles is pretty good. Now, we want these particles to be randomized. And so we're going to randomize three factors: their size, their speed, and their lifetime, how long they're alive for. So for their size, I'll say the minimum value is 4 and the max value is 8, and then we'll randomly select between those values. For their speed, I'll say 100 pixels per second and 600 pixels per second, and we'll randomly select between those values. And for their lifetime, how long they're alive for, I'll say 0.2 seconds and maybe 0.5 seconds. For their longest. So at the most, they'll live for a half a second. There are our constants for our particle system. What about for our bomb flash? So when we let off a bomb, we're going to flash the screen. How long do we want that flash to last for? Well, I think I kind of want it to last for as long as the radius is up. See, we're timing the radius. Let's go to our bomb system. Yeah, see how we have bomb duration seconds. It's set to 0.4 seconds. I'm just going to set our flash equal to bomb duration seconds so that those are always locked in. So we'll say bomb duration seconds. A nice tab for autocomplete there. So now our flash and the amount of time that we show our radius will be equal. I think that's going to work nice. And then lastly, when we take damage, we're going to shake our screen. So we've got two parameters here that we can adjust. First is the duration of that shake. I'm only going to shake the screen for about 1/3 of a second, 0.33. And then the strength of the shake. How much do I want that screen to shake? This is just going to be, the bigger the number, the more the shake. I'm going to set it to 10. And what we'll do is over time, we'll reduce that number. So it'll shake it like 10, and then we'll shake it to 8, and then 5, and then 2, and then 1, and the shake will subside. So it'll be like this. We'll take damage, and it'll be a big shake, and then a little shake, and a little shake, and then it'll be none. And it's going to happen super fast in 0.33 seconds, but we'll feel it, right? We might not see it completely, but you'll feel that shake. And the system's going to work really, really well. All right, our constants are set for our visual game polish. Let's go see what else we got in this lesson here for visual game polish. Any new colors? All right, we got a particle color. So our particle color looks to be the same color as the enemy's core. See how they match up? So when we shoot an enemy, we're going to create these pink particles that are the same color as the core. Like that's the part of the ship that just exploded. So I like that. And then let's see, gameplay variables. Ooh, let's see what we got outside of our student edit zone for our gameplay variables for our new polish systems. Okay, we've got an array for all of the particles that we create. Every single time we destroy a ship, we're going to make 25 particles. They need to go somewhere. They're going to go in this array. Perfect. We've got a timer for our bomb flash and a timer for our screen shake. So we'll set these, right? We'll set it to like, I don't know, we'll say for screen shake, it'll be set to 0.33 seconds. And that means shake the screen and we'll count it down. And as we count it down, we'll continue to shake the screen until it hits 0. And once it hits 0, then we know stop shaking the screen. So those timers are going to work really, really nicely for us. Okay, with our overview of those visual polish systems done, let's head to mission number 2. Mission number 2 says, you just made new systems. When you start a game or restart a game after dying, make sure you wipe those systems out. This is in Reset Game to Defaults, where we do all of our repositioning and wiping of systems. We reposition the player, the stars, the bullets, our bombs, our shield, our ramp, our enemies, our scores. And now we got to do the exact same thing to our polish systems. Imagine if I died and there were like 50 particles on the screen. When I restart my game, I shouldn't start with 50 particles on the screen. Those particles should be gone. So let's take the array, the container holding every single particle in our game, and let's empty it out. All right, and then let's do the same thing for our timers. So we'll set bomb flash timer seconds, tab for autocomplete right there, is equal to 0. So it's back to 0. And then screen shake timer seconds, again, tab for autocomplete, we'll set it to 0. Now our system is reset. So let's see, what system are we going to target first? All right, so we are going to target our generate particle data function in mission number 3. Now, a particle is something that we are spawning into the game. So we are going to continue to use that structure that we laid all the way back down in our first lesson. In our first lesson, when we were generating stars, we had generate star data, update or spawn stars, and update stars. And if you look, particles are no different. Generate particle data, spawn particles, update particles. So we're going to use those exact same things. Now, our generate particle data, it looks like we create a couple of constant variables, angle, speed, and life, and then we create a particle object that has the following properties: x, y, vx, vy, size, life seconds, max life seconds, and color. It looks like color is right. So our color should be that particle color that we created. That's going to be the core of our ship. So that looks pretty good. But all these values, they seem like they are probably wrong. And so let's figure out what we got to do here. So if you look, when we generate particle data, let's think about the first two properties of the particle, x and y. Right now, when we generate our particles, we are going to generate them at 200 and 200. So I don't know, will we actually make one? Whoa, there's our particle. We generated it at 200, 200. X coordinate 200, 200. 200 pixels in, 200 pixels down. That is a terrible looking particle. And it's always in the same spot. Let's change the size first. The size is currently 100 pixels. That's not good. We want to randomly create our size from particle size min. So it's going to be the second one because these are in alphabetical order, to particle size max, our first option. So now we set our size. So let's just refresh the game and let's see, do we get a more appropriately sized particle? Oh, I got to hit the ship. All right, so there's a particle. So that looks like it's pretty good. So that's much, much better. So we might be drawing a big particle and then smaller particles inside of it so you can't really tell. But I'm certain We are making more particles. We just can't see them because we're always making them that x coordinate 200, y coordinate 200. We don't really want that. We want the particles to start wherever the player was, or the enemy that we blew up, right? So if I blow up an enemy right here, I want the particles to start here, not up here. So right now, we got to change their x and y coordinates. If you look, when we generate particle data, we take in an x value and a y value. What I'm going to do is I'm going to double click on generate particle data and hit Command F or Control F to put it right here in my search bar. Let's see where we are generating our particle data. Oh, well, we're calling it inside of spawn particles, right? So when we generate our data, we're returning this object and we're returning it to spawn particles, which pushes it into the particle array. So we actually got to call spawn particles. I'm sorry about that. So let's look at spawn particles. And if we look, spawn particles happens in check player bullet enemy collisions. So we're spawning our particles and we're passing in the center of the enemy in the horizontal direction and the center of the enemy in the vertical direction that we collided with. This is the enemy's center X and this is the enemy's center Y that our bullet collided with. So we have access to that in mission 3. So in mission 3, we're passing in X and Y. We should set the X property of our particle to the X property that we passed in. We should set the Y property of our particle to the Y value we passed in. This is the center of our alien's X value and the center of the Y value. So with those changes, let's just see, will we now have them spawn exactly where the ship was? Yep, so there's that. Perfect. All right, so that's good. Perfect. That's good. That's good. All right, so now they're spawning correctly, but what we got to do is I think we got to move them. So we need to move them out in all directions. So if you look here, right now we have, Vx is 0, Vy is 0. Well, I have a speed variable. Okay, so speed is going to be chosen at random from 100 to 600. So can I just set them to speed? Speed, and Vy is speed. Let's see if that fixes it. All right. Nothing. I got nothing. Nothing, nothing, nothing. Well, it's probably because we're not updating our particles. Let's go take a look. We might come back to mission 3. We got a little bit of work to do here in mission 3. Let's go to mission 4. We might want to do these in tandem. Yeah, mission 4 says update particles. So in mission 4, we're looping through our entire array of particles backwards because we're probably going to want to remove them eventually. And it says move particles each frame and reduce their lifetime. Remove the particles when their life reaches 0. Okay, so let's move the particles. We've seen this structure before. We're going to do particle.x. We're going to take its x position and we're going to increase it by the particles horizontal velocity, Vx, times the time interval it moves, dt. And let's do the exact same thing in the vertical direction. Particle.y plus equals particle.vy times dt. And then it says remove particles when their life reaches 0. So if you look right here, we have if particle life seconds is less than or equal to 0. We ask that question, then we splice them. We get them out of the array. Well, you see how we have our life seconds right here? We just got to subtract from life seconds. So let's do that. We'll say particle.life seconds. We'll take their life seconds property and we're going to subtract dt. All right, so mission 4 looks great. Mission 4, we should now move them and subtract from their lifetime. So let's see if they actually move now. Whoa, they're moving. That's not the correct behavior though. They just move they're all moving in the same direction. And are they fading out? Not really. So let's go back to mission 3 because we got a few more things we got to target in here. Let's do the easy one first. The life seconds and max life seconds. I don't think those are set properly because right now they are set to 5,000. That is not what we want. We said, hey, we should set them to some minimum time of 0.2 seconds and a maximum time of 0.5 seconds. And we're randomly picking and storing it in this variable called life. So we're going to set the life seconds property to that life variable, as is the max life seconds. So when we create the particle, let's just say we randomly picked and we got 0.4 seconds. So their max life is 0.4 seconds and their current value of it is 0.4. And then we'll subtract from this. And when this value hits 0, according to our update, see, when that value hits 0, that's when we remove them. So right now, that should hopefully fix the timing of them. Let's just look. Oh, I missed that guy. Let's get this next one. It's hard to tell when they're all moving in that direction. Yeah, there we go. Now they're disappearing nicely. But we just got to change the direction that they move in. And I think what we need to do is change Vx and Vy. And we've got to somehow use this angle right here, okay? We got to somehow use that angle. And to help figure this out, I'm going to go to a whiteboard really quickly. Let's just assume we have two particles, and those two particles are going to move in different directions. That's what we want. So I'll do a blue particle, boop. So here's my blue particle that's going to start right there, and my blue particle is going to move off in this direction, okay? And then I have a red particle, and my red particle is going to move off in this direction. Now, what makes those directions different? So for each of these, let's just say we're moving with some speed, right? We're moving with some speed. Now, the blue arrow points up and to the right, but you can see how it's got a rightward part, zoop, right here, and an upward part that is much, much bigger. Its upward part is much bigger. Where our red arrow has a rightward part that is a lot bigger and an upward part that is smaller. So these represent Vx and Vy. This represents, in blue, Vx and Vy. We just have to figure out how we get those values. This is the actual speed of the particle. This is the actual speed of the particle. We have to figure out Vx and Vy, though, because we were using speed and it didn't work. So the way we do that is with some angle, theta. So angle theta. And we're going to talk about some trigonometry right here. So I'm going to draw a triangle. So here's our speed. Here is Vx, here is Vy, and here is an angle. So there's a nice relationship that says this adjacent side is related to the hypotenuse of the triangle, or the longest side, which is our speed, through a trig function called cosine. And it says the cosine of your angle theta is Vx, the adjacent side of your triangle, divided by your hypotenuse, our speed. So if I want to get Vx, I just multiply both sides by speed. And so I'm going to get cosine of my angle times speed is equal to our horizontal velocity, Vx. I'll put Vx first, actually. I think I would like to do that a little bit better. So I'll say Vx is equal to the cosine of theta times our speed. And our vertical velocity, or this side opposite our triangle, is related to the hypotenuse through a function called sine. So the sine of theta is our opposite side, Vy, over our hypotenuse of speed. Again, if I multiply speed to the other side, I get Vy. How much we move in the vertical direction is the sine of theta times our speed. And so those are the relationships we need to use. And what varies the direction that we move in is by just simply changing the angle. Here, the angle is small. Maybe it's only like, 20 degrees. Here, the angle is big. Maybe it's like 70 degrees. So we have an angle. I think the angle was defined for us in right here. Yep, see, angle is random 2 pi. So we're going to take our speed and let's multiply by the cosine, cos, of our angle. All right, times speed. And then in the vertical direction, excuse me, we're going to multiply by the sine of our angle times speed. And with that, I think our particle data is done. Our particle data is great. We're generating it. We're spawning it. We're updating it. We saw that we create these. We spawn particles anytime we destroy a ship. Let's check it out. Ooh, that looks nice. That looks really nice. They're moving in all directions, exactly the way we want them to. How about with a bomb? With a bomb, they do it. Oh, this is perfect. Our particle system looks wonderful. This makes the game exceptionally fun and engaging. But that's only one of the 3 visual systems that we are going to set up and implement. So let's look at system number 2. So going to mission number 5, this is our bomb flash overlay. All right, it says mission number 5. We're in a function called draw bomb flash overlay. Draw the bomb flash effect as a screen overlay. Make the flash appear briefly during the bomb effect. Okay, so mission 5. We are going to draw a rectangle that sits over our entire window and then flashes a specific color, the first thing we should do is probably put that color in our paint bucket. So we're going to fill with bomb flash, not flash duration, bomb flash color. Oh, we don't have bomb flash color. We're going to use bomb fill color. We're going to use the same color. Yeah, and that's going to look nice. Our bomb fill color is that transparent pink. So we're going to flash that transparent pink over the entire screen. And so what we're going to do that is create a rect starting at x coordinate 0, y coordinate 0, whose width is the width of our canvas and whose height is the height of our canvas. And let's see. Now when I do that, do we actually draw that rectangle? Let's just check it out. Bomb. No, I don't see it at all. Well, we probably got to go to mission 6. We wrote the code. Are we calling the code? Well, mission 6 says show the bomb flash effect. And so this finds us in draw scene. Draw scene we do a lot. Okay, it looks like we are something to do with our screen shake here that we'll look at later. But we're drawing our background, our enemies, our bullets, our bomb, our particles, our systems. Perfect. And then we have our overlays. So here are our overlays that we only draw if certain conditions are met, like if we're in the start state or the lose state. Well, our bomb flash is another overlay. So we're going to ask a question. If some question is true, then what do we want to do? We want to draw bomb flash overlay. We'll call that function. Now, we only want to draw our bomb flash if our timer is set and is greater than 0. Remember that timer we discussed? We said bomb flash timer seconds. Here it is, second in my list, tab for autocomplete. If that is greater than 0, then we want to draw our overlay. It means we just launched a bomb. So let's take a look. Let's see if this works. All right, here we go. I'm going to put a bomb. And there is our screen flash. The whole screen flashes nice and pink. Now, we'll talk about a couple of things here. The first thing that we're going to do is we're going to go back down to draw bomb flash overlay. All right, here it is. If you notice, this line right here is the line that is making it flash. And one of the things we can do is we can make the flash faster or slower by simply changing this number right here. So let's watch what happens if we change it to, instead of 12, let's make it like 40. What happens to our flash? It's much, much faster. If I make it smaller, let's make it like 6. It's much slower. So we can adjust the rate of the flashing here by just changing that number. And I'm going to put it back to 12. Now, the other thing that we want to talk about here before we leave our bomb flash system is we are only running this if our timer is greater than or equal to 0. Well, I have a new function called update polish timers. You can see that I'm updating our flash timer by subtracting dt. I'm updating our shake timer by subtracting dt. And if they're less than 0, I set them equal to 0. So we are subtracting. Where are we setting the timer? Well, we're probably setting it whenever we press the bomb key. So in our key pressed function, if we look, we press the bomb key, we create a bomb through spawn bomb. So let's go look at spawn bomb. I'll hit Command F, Control F to put this in my search bar, and it'll bring me right here. I create an active bomb, and right there is where I set that timer. So I'm setting the timer, and then I'm decreasing from it. Wonderful. So the bomb flash overlay system is working great. I think our last system is just our screen shake. So if I come to mission 7, it puts us in draw scene. We create two variables here, shake X and shake Y, and we declare them using let because we're not going to keep them at 0. These are going to be variables that we use to determine how much we shake in the X direction and how much we shake in the Y direction. We said that we want to start our shake really strong and then make it less and less and less. And so we're going to use these two values right here, shake percent and current shake. We check if our shake timer is greater than 0, it means we are going to shake our screen. So we're going to take that shake percent and we're going to change it. Now, we want to make it be really big and then decrease and decrease and decrease. Our percent should be somewhere between 0 and 1. So at its maximum value, it's going to be at 1, and when it's done, it should reach 0. The way we can think about this is by thinking about a fraction. So let's put a value in the denominator and a value in the numerator. 20 out of 20, well, that is equal to 1. And if I set it to 15 out of 20, so I decrease the numerator, okay, now that's equal to 0.75. If I set it to 10 out of 20, it's equal to 0.5. 5 out of 20, it's equal to 0.25. And then finally, when it's 0 out of 20, the shake percent is 0. So we've decreased that amount. So the denominator is the thing that is always going to stay the same. It is the maximum amount that you have. And so what I'm going to put in here is the damage shake duration seconds. It is 0.33 seconds. This is our maximum amount of time that we have to shake. And then the longer we shake, the weaker our shake should get. So our numerator, the thing that is going to start at 0.33 and then decrease to 0.32 and 0.31 and 0.30, 0.29, on and on and on, all the way to 0.03, 0.2, 0.1, and 0 is our screen shake timer seconds. So that's our timer. Screen shake timer seconds. We set it to this and then we decrease it. And so then we're going to get a lower and lower shake percent. And we're going to use that shake percent to update the current shake amount. Our current shake amount is going to be our starting damage shake strength, which what did we set it to? 10. And we'll multiply by our shake percent. So by the time shake percent is 0, our current shake 0 times 10 is 0, and we've killed it. Then we figure out our shake X and our shake Y by randomly selecting from the current shake the left value, the right value, the upwards value, the downwards value, and we are going to use those to shake our screen. Now, we've set those values in mission 7, but we have to apply them in mission 8. And so mission 8, we see something new here. We see push, and then all the way down here, we see pop. So push and pop is a nice way that you can apply certain drawing effects to only a region of your screen. So we're going to push, which says, hey, we're about to apply a drawing effect. Only apply it to the stuff that is in between push and pop. So we're going to shake our screen. And when we shake our screen, if you look, what's in between push and pop? We're going to shake our background, our player bullets, our enemy bullets, our bomb, our particles, our enemies, and our player. Then out here, we draw our HUD. So when I shake the screen, everything down here is going to shake, but not the HUD. The HUD will not shake because it sort of exists separately of the game world. So all we need to do is issue the command that shakes our screen. And the way we do that is with a translate function. To translate means move back and forth. Move it in the X direction and the Y direction. You just have to specify how much you want to move in the X direction and how much you want to move in the Y direction. And we have those values, shake X and shake Y. We calculated those in mission number 7. So I'm going to pass in shake X. I'm going to pass in shake Y. Those are going to get randomly changed every single time we call draw scene. If our timer is set, we're going to randomize them. We're going to randomize them large, and then they're going to get smaller and smaller and smaller. And so they're going to shake up and down, left and right, over and over and over again. All right, let's test this out. Let's test out the screen shake. I'm going to take some damage on purpose. And there's our shake. All right, that looks really good. Everything shakes except for our HUD. Our HUD does not shake, which is exactly what we want to have happen. That HUD is stationary. Yeah, perfect. Really, really good. All right, now before we do one final playtest here of our game, if you notice, our ramp is still showing, and that was super helpful when we were debugging the game, when we needed to figure out if the ramp was working. But we know the ramp is working right now, so I don't want that that readout being shown. So we're going to take that line out. So if I go to draw HUD, all right, right down here, it's my line 758. If I scroll down, here's our line where we were drawing the ramp readout. We can just simply comment that line out. Commenting that line out, the ramp is gone. Perfect. And now we're like in our full play mode. If we need to do some debugging and bring it back in, we just uncomment it and that ramp shows back up. Perfect. So let's comment it out again. And with that, we are officially done with Nova Strike. Let's do a full playthrough and see how we do. So right now, I'll refresh my game. All right, we're in our start state. Nice start menu right here. I'll press enter to begin. I'm going to fly my Nova commander. Oh, blowing up alien ships. That looks great. Very good. Ooh, I better watch out. Drop a bomb. Nice overlay there with the bomb flash. That looked wonderful. Ooh, I took some damage. The screen shook nicely. Ooh, I took some more damage. All right. Can I get myself... I'm going to use another bomb here. Destroy those. And another... Oh, I was really hoping he would fly into that bomb zone. I'm out of bombs. That's not good. But if I get to 1,500 points, I should get another bomb back. Ooh, and I do. I'm going to use it immediately. because I need to. All right. So the game is scaling up in difficulty. I feel the enemy pressure increasing as we play longer and longer and longer. More enemies are spawning. They're moving faster. They're firing faster. All right. So this is, oh, ouch. All right, I just got another bomb back. I should use it. That was a bad use. I only got one enemy. I think I got one more hit left in me. The enemies are bouncing off of the screen quite nicely here. All right. Another bomb rewarded. That one did some good damage. Now look at this. Oh, we got lots of enemies spawning, and I have died with my high score of 5,200 points. That was a really fun game. Play it again if I want to, and I will, but I won't force you to watch me play it. I know you don't want to do that. You want to play this game yourself. You want to see if you can beat my high score of 5,200 points. This was a great game. I'm really happy with how this turned out. One of the things I liked the most about this game here was that we had repeated structure that we used over and over and over again. We started with introducing star objects, and then it was bullet objects, and then it was our enemy objects, and then our bomb object. Each time we worked on a repeated structure of generating data for that object, spawning that object, and then updating that object. And with that system, we could expand this game like in a lot of great ways. Like maybe you wanted to add power-ups. Generate the data for the power-ups, spawn the power-ups, update the power-ups. It's literally that easy. And maybe that's something we'll talk about doing in our next video. So I'll see you then.